I'm going to show you how to use these maps. These maps are very intuitive, so you should have no problem navigating them. I just want to make sure that you take full advantage of what is in these maps. So it's always going to take a little bit to load up the data. If it doesn't load up the data, just reload the page. The settings and all this information is here. You're welcome to look through some definitions, some notes, but we're not going to go through that. You can do a lot of really cool stuff with a map. First thing we're going to look at is the probability of collapse, because that's what we're starting with. So all right, so look at the probability of collapse. And it's only with the model of ASC 7, so those are the requirements. And I'm going to go with site class D. I can select the entire US just because I can handle it on my data. But if your system can't, you don't have such a big screen or something like that, you can pick a smaller sub-regionalization. So I'm going to pick the entire US. Right? So otherwise you could pick other ones. So I'm going to pick the entire US, and then of course I only have one choice, and this shows me these are all the states involved. It says 49 because some reason. Oh, I think the District of Columbia is also there. All right. So go ahead and pick that data. You'll see here that it's loading this. It'll take a bit because I'm loading up the entire US. I'm home, so it really depends on where you are and the rendering. And you may actually have bad luck and not be able to load everything up. There it is. What we can do is you can close the controls and we can look at these data. Here you've got your scale. So we've got the highest value is 13%, which is really where these red zones are. So here I can zoom in and I can, but you see how it takes a while? So if you really want to do more interaction on the data, I recommend that you load up just the regions you're interested. My system can handle it. I'm going to click here. It takes a little bit of time, but it's not as fast. I mean, if it's not fast on my computer, and I can plot the MPRS. In this case, it's over all periods, but we're looking at the probability of collapse. All the periods are in one file, and that's why I can load them up in this case. And again, this is for site class D, and it's shown right here. So what we could do is, if we're really interested in looking in the details of this, what I would do is I would do a new data set, clear everything up. Now only go to California. So I'm going to do the smallest possible. If you want, you could do, maybe a way to do it would be 11 regions. You know, that's this one here. So I can look at the Pacific North, you know, the whole West Coast. All right, so I could do this. It's loading up the data. And now I can navigate a lot more easily. It's a lot faster, so I can plot the MPRS. Oh, I wanted to do a different. I can look at mapped values for the different periods. So this is the values at 2 seconds. You see that the maximum value has gone down from 13 to 2.8. So let's do a site class BC, same region. And now the maximum value is 8.8% for the 0.2 second. What's really interesting is if you zoom into this map, I just use the mouse. You could use the little thing here. This just gives you this. Here you can actually, so let's turn on where the faults are. It's fascinating to see where the faults are. And I'm going to turn on all the populations. What we see is that these really hot red spots don't really have such a large population, because if we look at the OpenStreetMap, or satellite, I think is the one. Those are those beautiful hilltops that you see when you're driving on the 5. Terrain may show it better. Okay. Still, there's a lot of highly populated regions that have yellow. So maybe you can look at this, and let's look at all the periods. So in site class BC, it's actually the short period range that has it really high. So that's deterministically capped, while here we're getting closer to not. This is controlled by the probabilistic. So this is the probability of collapse data. And you can really just look at whatever you want for your site. Now, new data set. What's the next thing on our items? ASC 722 MCE sub R spectral acceleration. So these you can get anywhere right now. These are the values. So if I'm going to look for PSA, And I'm going to look at National Seismic Hazard Map model of 2018. There's two grids because you have original data and really highly gridded data. Again, that's going to take a while to load up. This may be easier. This is what all the 2023 hazard model data is in a grid of 0.1 instead of 0.05. So this is going to load faster, but hey, let's do it like this. So I'm going to do the entire US, get the region data. It's going to take a while to load up, but it's kind of cool to watch it. In the meantime, you really shouldn't be messing with the maps, but I like this map because it's just got the best contrast for the data. Whoa, there it is. It crashed. You just reload and start over. 2018, ASC 7. I don't want the default site class. Let's do a site class D. I'm going to do the whole US. Oh, but I'm not going to do that one. I'm going to do the 2026 grid. It's okay because I want a big picture. If I then want to look at detailed data, I will do a better grid. And I'm going to go back to site D, this, and this. Now I'm going to get the map. This loads up the data into memory for all periods so that we can plot the multi-period response spectrum. Therefore, this is going to slow things down a bit. As you hover, you can see numbers. You can close this. If you click on something and you say plot the MPRS, there's the plot there. Ooh. Or some people like it log. Or if you want, you can put it into a separate pop-up. This separate pop-up is going to be, you can set it aside. It's never going to be closed until you close it yourself, either here or here. Okay. I recommend you use the close so that it knows that you've closed it. So I did this so that you can save, and compare different sites. All right, I'm going to close this. I want to show you that you can do filters. So I'm going to filter. Even though I'm going to look at the data at 1 second, but I'm going to apply the filter where the PGA is greater than 0.1. Okay, so you don't have to filter just on the data that you're looking at. You can filter on any other data. So we're going to change this. And yes, that moves the map, I know. You have no idea how difficult it is to make maps. Apply the filter. Ha ha! So this tells you, this little goose, this is in the US where the PGA is greater than between 0.1 for this site class, okay? Pretty handy. All right, so this is really helpful data. You see, it's a coarser resolution if you want to do the higher resolution. So now let's go to do something fun. These are the new values. And you could do exactly the same thing as what I showed you with the ASC 722. So I'm going to jump to the fact of the ratios, okay? There's two ways that you can do the ratios. You can upload only the ratio data if you want. This is a lot less data because you're only getting the, 1 column per period. If you do spectral acceleration and values, so now you have 3 times as much data because you've got the 2 spectral accelerations and the ratio between them. It's pre-calculated, so it's more data. It's faster for rendering, okay? So I'm going to do, give me spectral acceleration ratio. There's 2 kinds of ratios you can see. One is between what we're doing now with proposal versus ASC 722, or you can even look at 23 versus 23, just if you want to compare the 1%. Here, you can compare the 1.5 to the 1.0%, or the deterministic to the 1.0. But let's go here. This is the exciting stuff. What would be the change if we have a 1.5% probability of collapse purely uniformly risk targeted across the US for a site class D? I'm going to do the full US, and I'm going to say, get me the data. It's a lot of data. Okay, there it is. Now, be careful because we've seen this before, because what I do is I just load it up for the very first value, okay? So these first ones are ASC 7. These are the numerator, okay? And then this is the ratio. So I want to look at the ratio at 1 second. And the label here tells you it's got to render. Okay, so now things get interesting because you're like, oh my gosh, the highest ratios are over here. And yes, these changes are significant. You know, we thought it would be bad over here. This is highly dependent on period and site class, okay? Because MCE sub R is highly dependent on period and site class because of the deterministic capping. What I want to make sure is that you look at the proper data. So I'm going to add a filter because this is a ratio of something divided by something else. If that something else is really, really small, so I'm going to just say where the PGA, but if you want, maybe the best thing to do would be where the spectral acceleration in the denominator, therefore 1 second from the MCE sub R. Okay, so those are the bounds. I want that to be at least 0.1 G. You can pick this whatever you want. I'm not setting a cap on it. And now I'm going to say apply the filter. And you'll see that some of these red spots, not all of them, are going to disappear. All right. So I'm keeping the color map to be the same for the US, independent of your filtering, because otherwise things can really get misinterpreted. But now we've seen at least that these regions are really high ratios. Yes, this is it. This is what's happening in these places. So now let's plot the MPRS. Here's a ratio. It's relatively high. Okay, so spectral acceleration values are going to go up a lot. But hey, we're looking at values. It's so difficult to see these values in linear plot. Okay, makes so much more sense logarithmically. So this is 0.1 is here, okay? Because we're right on the border, right? So yes, these values are large, but these spectral acceleration values are relatively small, okay? So that's what the purpose of this plot is, to show you the ratio at the top and then the two relative values. There are places where the two lines actually cross each other, so it's not always up. So for example, if we go, and it's interesting because we're concerned that we're going to a higher risk target. Well, yeah, look over here, we definitely have a drop. And if you want, that's where you can filter the data based on the ratio. Here, instead of doing the spectral acceleration, say, hey, give me where the ratio is less than a certain amount to evaluate things. And so yes, this ratio is really low in this region, but we're looking at very low values of spectral accelerations as well. Okay, so make your decision on your evaluation on these data and the recommendations. I'm providing this to give you, oh, look at that pretty picture. There's some spot. If we go to San Jose, I know everybody wants to know what's going on in San Jose, and it's tricky because, you know, what's the hot spot in San Jose? It's actually down here that this hot spot is, which is not quite San Jose proper, I think. Where is San Jose? I need to add the sites, the test sites, but I don't want to influence the data. See, look at this, and not so much here, but the 2023 model does cross the ASC7 in the long period range. And that's it. Enjoy.